Remember the first time you tried long division with numbers and felt like giving up. Now picture that same division, but with variables, powers, and negatives all mixed in. Sounds like chaos. But here's the good news. Once you understand the pattern, this chaos turns into clarity. Algebraic long division isn't about memorizing formulas. It's about thinking step by step, just like regular division. So don't worry if it looks scary right now, because I'm going to break it down so simply, you'll wonder why no one showed you this before. This is Global Math Mentor. Let's break down algebraic long division together. Let's take a look at this first problem. I'm calling it easy division. The reason is that you are dividing a cubic polynomial by a simple constant, 3. This top value is known as the dividend, and the denominator is known as the divisor. So let's put the division bar like this and put the dividend inside. 3x cubed minus 6x squared plus 9x and minus 12. Put the divisor outside. Now, this is where the algebraic long division is slightly different from the number long division. You need to match this first expression. So it means that you need a 3x cube over here. How do you get it? What expression do you multiply with 3? So if you multiply 3 with the x cube, you will get 3x cubed. So that's the first step, okay? So, and you remember from your number long division that you subtract the lower value or the lower expression from the top one. So when you subtract, I like putting these signs over here because previously 3x cubed was a positive one, but the reason when you subtract, the positives become negative or the sign changes. So this cancels. And then pull down the rest of the values. So 3x squared plus 9x and minus 12. And I don't need this now because I need another number here or the expression here. What do you multiply 3 with in order to get negative 6x squared? One way to think about it is that in your head, you can divide negative 6x squared by 3. What expression do you come across? It's a negative 2x squared. So if you multiply with a negative 2x squared, you will get a negative 6x squared. So you need to cancel it by changing the sign, and there it goes. So I can erase this. Whatever way you can do it, either divide it or just think straight away, like pull down this 9x and minus 12. What do you multiply 3 with in order to make it a 9x? So multiply this with plus 3x. So 9x, and you subtract again. There we go. And you're left just with negative 12. So now 3 will be multiplied with the negative 4. And this will become negative 12. And here the division ends. The remainder is 0. Okay? So this value on the top is known as the quotient. So in part 2, I'm going to divide a cubic polynomial, this time with a linear expression, which is a binomial with a variable. So let's put the division bar. And before we move on to the process, make sure you're noting this down. Or maybe you can pause the video and give it a go yourself. And then you can check my work. So what makes x cubed if you multiply it with x squared? So this is x cubed. And this time, there is a minus x squared as well. Why? Because you can think it this way, that x minus 1, this expression is being multiplied with x squared. So x times with x squared, that's the x cubed. And negative 1 times the x squared is a negative x squared. Right? So that's how you get this expression. Unlike the previous division where we were only getting just one single term. So subtract the lower expression and this goes away and this goes away as well. So we have minus x plus 1. Now I multiply with the negative 1. So negative x plus 1. And this time we get a 0 remainder again. So another important thing which you can think is when you get a 0 remainder, your quotient, this value on the top, is also a factor of dividend. So this linear divisor is also a factor because it's giving a zero remainder, and the quotient is also a factor of the dividend. So if you want another like a very simple example why this is true, think of the number division you used to do back when you were quite younger. Like if you have 14 and you divide by 2, 2 7 times 14, you get a zero remainder. So 2 is a factor of 14, but is 7 a factor of 14 as well? Yes, that is true, right? Part 3, these are harder divisions. You'll see why, because there will be missing terms or remainders. Let's see what does that mean. So put the dividend inside the division bar and the divisor outside. So let's go the usual way. X cube in order to make this x4. But now when you time -2 with x cube, you don't have the x cube term over here. So you can just write it to the side, 2x cube. And when you subtract the lower expression from the top one, the signs change anyway. So this cancels. This will be 2x cube minus 16. Now we time it plus 2x squared. This will be 2x cube. Again, I'm getting a term, a -4x squared. The reason I'm not writing it underneath 16 so that you don't get confused how to add them. So you can write them separately because that's the x squared term and 16 is a constant term. So subtract this and you have 4x squared minus 16. Keep going. Plus 4x. Okay, let me just produce the bar. 4x, that's going to be 4x squared and a -8x, right? I think you get it now because -2 times with 4x as well, and that gives you a -8x, which will not be like term to -16. So now we subtract this and we are left with 8x minus 16. And now finally I time this with 8, and this will give me 8x minus 16. And again, I'm getting a zero remainder, which obviously makes sense that the quotient is a factor, which is a cubic factor, and divisor is a linear factor. But this is how you do long division when there are missing terms. Part 4, dividing by quadratics. So you see your divisor is a quadratic polynomial, but your dividend is a quartic polynomial. Let's go. Put the dividend inside the division bar, minus x plus 5. And now we put the divisor outside, x squared minus x plus 1. So this will be 2x squared to get a 2x to the power of 4. Subtract, and this will be -2x cube. But you see there's a missing term again, no x squared term. When 1 times with 2x squared, you write that to the side. Subtract these and this will cancel. We have 3x cubed minus 2x squared minus x and plus 5. Now there is no missing term. Let's go again. Plus 3x. This will give you 3x cubed minus 3x squared plus 3x. And minus plus minus cancel. X squared minus 4x plus 5. And finally, I'll time with 1 to get x squared and minus x and plus 1. This time, this divisor is not a factor. You'll see why, because we are getting a remainder of minus 3x plus 4. This is the remainder, the top value is a quotient, and that's how you perform these divisions. And usually these kind of questions pop up on the exam, in the IB, in the A levels. And there is a special form as well, which we write. Like, I'll give you a simpler example again. Back in doing number long division, way back, if you had like 13 and 2, 6 times 12, you used to write your mixed number as 3 whole 1 over 2, which can also be written as 6 plus a 1/2. This you need to get yourself familiar with. Any improper division can be written as quotient plus remainder over divisor. So what's that? Quotient plus remainder over divisor, right? So if I wish to write this, I mean, that's not the requirement, but while doing series expansion or integration questions later on in the calculus course, so you'll find out that writing this final answer like this helps you solve the rest of the problem. Plus, I can write the remainder like 4 minus 3x and divide the whole thing with x squared minus x plus 1. You can see that this is the answer in the form quotient plus remainder over divisor. So here is another advanced type. So this time, the dividend contains unknowns. So the algebraic coefficients, you can see that my dividend has a missing or an unknown coefficient of x. How do you perform division in such cases? So they are saying find a such that the remainder is 0. Let's go. Okay, so this will be x squared plus ax plus 6. And I'll write my divisor outside, which is a linear. And another way of looking at this problem is that you can say that x plus 2 is a factor of this polynomial. So x times this gives you x squared plus 2x. And this is where things get a little tricky. Cancel. How do you subtract this? If you do your algebra minus 2x, you can factorize the x. So this will look like a minus 2 and x. So now that is the coefficient, the term in x, and this is the constant term. Okay. So now how do you make it a minus 2 times x? Just time the divisor with a minus 2, and this will give you a minus 2 times x and plus 2 times a minus a 2. Okay. Subtract, and this goes away. So now you know that the remainder is 0. So how do you get a remainder 0? When you subtract 6 minus 2 times a minus 2, this will end up 0. And I can write it 6 minus 2a plus 4 equals to 0, 10 equals to 2a, and a equals to 5. I hope you get this one. In the last part of the video, I'm going to solve an actual exam question from the CIE A levels. Let's go. A part. Find the quotient when this is divided by this. So we see it's a cubic polynomial and it's divided by a quadratic polynomial, and show that the remainder is 18. Okay, so we write the divisor outside, classic long division problem, and put the dividend inside, 4x cubed plus 17x squared plus 9x. Okay, this goes like 4x, which will be 4x cubed plus 20x squared plus 24x. Okay, so we subtract the lower value, which will be negative 3x squared and a negative 15x. Now we time with a negative 3. This will become negative 3x squared minus 15x and minus 18. Okay, when you subtract it, you will get 18 as remainder, which was required. So we had to show that 18 is the remainder. So this is my remainder. Okay, and this is the quotient which was required. So that's part A. Next part. So how can we solve cubic equations using like these quotients and remainders? Let's go. So any polynomial in long division, another simpler example, you can think it this way, like if you have 13 and you divide it by 2, 2 6 times 12. Now be careful, how do you write it? This will be dividend will be equal to divisor into quotient and plus remainder. So you get it, like any division follows this path. So I can write this cubic polynomial. Let's say, let's denote the cubic polynomial as px. Okay, I'm running out of space. So px can be written as divisor x squared plus 5x plus 6 into quotient and plus remainder, which is 18. So that is my answer from part A. But you can see that there is an additional thing. They have subtracted a minus 18 as well. If you want to check what I'm saying, this dividend was different, but this time there is a minus 18 as well. So in the B part, if you want to solve this equation, you'll subtract an 18, which will be equal to 0. So now all we are left with is this divisor, which is a quadratic one, and this linear factor. This becomes now a factor because this is equal to 0 now. So let's how do you factorize this part? This will be, x plus 3 and x plus 2 and 4x minus 3. And hence, I can write the final roots of this cubic equation like x equals to minus 2, x equals to minus 3, and x equals to 3 over 4. Right? So this was like an additional information because it came in the exam question. So you can extend the ideas from division and into solving equations. In my next videos, I'll give you more explanation on factors and remainders and a theorem known as the remainder theorem and factor theorem. And that's it for algebraic long division. It wasn't that scary as it looked. Just follow the step and it works every time. If this helped you out, drop a like, hit subscribe button, and keep the math momentum going on. See you in the next video. This is Global Math Mentor, over and out.